This is an early 1930s Detrola 6-tube AM radio. The model, I believe, is a Morse, as that is what it says on the tuning cover badge. It's in pretty rough shape and very dirty. It's missing the tuning knob, the cabinet is falling apart, but otherwise it seems complete. There's no information whatsoever on the interwebs for this radio, but we will attempt to repair it and bring it back to working order. So if this interests you, stay tuned. Alrighty, let's get into this old girl. So I saw this on the interwebs, and I just had to have it. I like to do odd stuff and rare stuff if possible, and like I said in the intro, this is definitely pretty rare. There's no pictures, no schematics, no information whatsoever. So this is the earliest radio I've ever worked on. I usually like to do 1936-ish to 1946-ish. That's the tube radios I like to work on, but I'm guessing this one is maybe 1932 or 33. Let me give you a close-up of the tuning cover. So it says Morse on it, and there was a Morse brand radio, but this is, at least I'm pretty sure, Detrola. So on the back, it says made by DR Co. Detroit, which should be Detroit Radio Company, Detrola. I'm pretty sure. I looked at some other Detrola radios and it had the same badge, so this is it. Pretty cool, but it's really dirty, and I have no schematic. So what I plan to do is take it out of the case and clean it up a bit and see if I can write out a schematic for it, because I'm sure it's going to need some work. So let me get it out, clean it up, and we'll be back. Alright, I thought I'd show some film of this before I cleaned it up, and I started looking around, and I don't I'm not quite sure what to say. I don't think it's a Detrola. It might have, I don't know, been assembled by Detrola or whatever, but on the tuning dial here and on the tuning cap, we have De Jure Amsco of New York. So I did I asked the internet about it, and it was according to the Radio Museum, was a radio company in New York, and they have one model listed, It's not the same as this one because it has different tubes, but anyway, this radio might be rarer than I originally thought. So, yeah. And another bummer is this tuning shaft is missing. So I'm going to have to get the lathe out and make something for that. I think I have an old Majestic chassis that has the same kind of tuner deal on there, so I'll have to take a look at that. But anyway, man, this thing is filthy. This thing must have been in an attic or in a dirty garage or a barn. And whoo, she's dirty. Oh, one other thing I forgot to mention, the speaker got a little hole put in it. Luckily it wasn't a lot worse. The screws gave on the cabinet. Unfortunately, I told the shipper to pack the inside of the radio with bubble wrap, and that saved not only the speaker, but boy, that thing rattling around in there, who knows what kind of damage that would have done. So, yeah, a de jure Amsco. It says it too on this tuning cap here. So after we clean it up, we'll have to do a little more investigating and see if there's any other markings I can find on it. So pretty cool. Very cool. Take it outside and clean it up a bit, and we'll be back. Okay. We have a civilized cleaning done on it. And I'll tell you what works really good is this grease lightning stuff. I think I used to buy it at Menards. My Menards doesn't have it anymore, so I had to buy some more on Amazon. Man, it's a really good cleaner. So another thing I wanted to show is they make these marker books with labels that you can for the speaker. I labeled everything and marked it on the speaker, so that makes it nice and easy to identify where your wires go. So let's flip it over and have a look-see at the underside. I haven't even really looked at it yet. All right. Let me pause this just for a second. All right, sorry about that. I had to put a block of wood under the transformer to keep it from tipping over. So this is the innards. Boy, that looks all original, but I see a couple things here. So, boy, we have a resistor that has blown up. Well, that must have caused a fire, because this paper cap, is this paper cap? These two paper caps are black, and let's see, this thing. What the hell is that? So, just a quick glance, everything looks all original. All original capacitors, resistors. But that one, yeah, see, it's all burned around here. Something got hot, short-circuited. I don't know. But it blew that resistor up. Let me get the close-up camera and we'll get a better look at it. Alright, so that is our blowed up dog bone resistor. Woof, huh? Very interesting. Be handy to have a schematic to know what the hell it is. So, anyway. Fortunately, on these old radios, they're relatively simple as far as not a million parts in it, so I'll probably spend the next couple days making a schematic for it. And I'm really excited about this. This is really cool. Who knows if this is the only one in existence? I don't know. Certainly can't be that many of them. And hopefully we can get it working. So I'll get to work and hopefully we'll get a schematic. Okay, we're back. We have a few updates. I had originally in the intro said this was a Detrola. Then after looking around a bit, I changed it to a de jure. And now I'm back to Detrola. The main reason being, man, I did a lot of research trying to find out information on the de jure deal. And as it turns out, de jure mostly did radio parts, at least. So this radio is either, I think, a 1933 or 34 radio. And back then, they made tuning caps and stuff like that. So, like I said, I'm back to it being a Detrola because it has that badge on the back. And yeah. So Detrola made the tuning capacitor. I don't know if there's any other parts in there, but what made me originally think it was a de jure was the Radio Museum had the, I think it's this one right here, has a radio listed under the de jure brand name, and I don't know if someone did the same thing as I did. There were no markings on the radio, and they saw that de jure on the tuning cap and went with that. I don't know. But anyway, we're going to call it a Detrola. So I got the schematic done, and it went way better than I thought it would be. So it came out really good. It only took me about a day and a half, and usually this would take a lot longer, but there's a lot less components in this radio being so old. So what really helped me out was I looked around on Radio Museum under Detrola. I found a Warwick badged radio made by Detrola, and I get Detrola and Warwick are the same things. I don't know, but anyway, it has the same tubes, except ours has two 47s, two output tubes, which is pretty remarkable. But this helped tremendously because a lot of those caps in the radio are they have tar all over them or something. I tried cleaning them to see if I could read what the values were, but this thing really helped me out, get everything laid out and whatnot. And the way I did it is I go ahead and just pencil and paper, draw everything out, and then I take a scan of it. I open it up in Paint, and I just, with the marker, yellow highlighter and whatnot, I go in and when I'm drawing the schematic, I'll paint the line so I don't miss anything and get everything figured out, and that gets us a nice schematic. So worked out pretty good. Some other good news: I ohmed out all the transformers, power transformer, IF, antenna, and all that, and everything ohmed out to what I think is good. Nothing open, which would be really, really bad. And I guess it's possible there could be a short somewhere, but everything seems to be good. And I need to test the tubes yet. I'm going to test those and see if any of them are bad. I'm seeing my tube guy next week, and I'm going to pick up a set of tubes for this radio. So, and I did happen to notice I didn't think there were any replacement parts in this, but that cap there is a replacement. I think that's the only thing that was ever replaced in there. So I don't know why these these capacitors, some are tar covered, some are not. I don't really know what's up with that. If they got hot. I was under the impression they're all filled with wax. Maybe these really older ones are filled with tar. Maybe some are filled with tar, some are filled with wax. I don't know. But we're getting close to firing it up. I'm going to do a kind of a close-up fly through the radio here, and we'll take a look at all the components a little closer, get everything documented, because I think, like I said, this is a pretty rare radio. So we'll do a close-up go-through of this radio and look at all the components, document them. So this capacitor here, I had to desolder it so I could trace the wires behind there, but this is really cool to see everything nice and original. This is one of these weird Potter made those capacitors, and they're like a sandwiched layered film deal. I don't know really what the deal is. Here's another one there, and then there's one right here, and this is the one cap that was replaced. So wiring's in amazingly good shape. So just trying to document all these pieces, parts of the radio, because it's such a rare radio. Really cool. So just in case someone ever comes across one of these, it's been monkeyed up, well, be able to have a reference. So anyway, we'll be back. Alrighty. It's actually been about 3 weeks since I've worked on this radio. I'm getting over a cold. It wasn't too bad, but my voice was absolutely terrible, so I didn't want to do any recording. Well, it sounded so bad, not that it's great otherwise, but and then we had almost a foot of snow in early November, which is kind of crazy, so all kinds of stuff going on, so I haven't had any videos out for a little bit, so I'm going to try to fix that. So anywho, back to the radio. So I tested the tubes, and 3 of them were bad. The 57 tube was dead, and both of the 47 tubes dead as a doornail. All 3 had no, they didn't light up, they just completely dead. But the other, what do we got, 58 tube and 55 tube, I think, they tested good, so I have the new ones in the back, and the switch was being kind of wonky, and that's kind of unfortunate because it's all riveted together, so I just for now jumped it and replaced all the capacitors. And since I don't know if this is going to be a working radio, I just kind of put them in very loosely, so to speak. Not exactly the safest way to do it, but
it's amazing what you can accomplish when you throw safety out the window.
you do what you got to do. In case it's a complete dud, I can just take all the parts out and salvage it. And I got the speaker wired in here with jumper wires, so it's don't try this at home, kind of dangerous, so we'll try and be careful. So I have a meter hooked up, we'll monitor the B+, which I have no idea what it's supposed to be. All I know is it should be under 250 volts of DC. So I think we're good to go to fire it up and see what it does. So this is kind of exciting. I hope it works. So I'm going to bring it up slowly on the variac. Not so much because I'm worried about reforming capacitors because they're all replaced, but just any kind of short circuit somewhere or something heating up. So the bulbs will, in theory, protect us from that. So let's flip it on and apply a little voltage and put our first bulb on, and everything seems to be okay. Yeah, filament is heating up. It is good. A little nervous. That's about 70 volts. Very little current draw, which I guess is good, but at the same time it could be bad. No DC voltage. I did check the field coil. That was good. Oh. Boy, it will be something if this thing works. Now, anyone that's watched my videos knows that I occasionally forget to do things when powering it up. But I have the on-off switch jumpered. Huh. No DC voltage whatsoever. It's possible those jumper wires are not making good connection on the field coil. All right, let me pause the video here and snoop around a little bit. Okay, we do have DC voltage. It was just a bad connection with the voltmeter. So that's good. So we only got about a little over 60 volts of AC going to the radio. So let's I got 120 volts on the variac. $65 volts DC, probably not enough. Oh, a little crackling on the speaker. All right, let's give it a bulb. I'll be darned. It works. Kinda. Or shall I say it's making noise. Whoop. The volume doesn't go all the way down. Even the dial lamp actually works. You can't see it. It's a 2.5 volt bulb. So let's see, 186, 187 DC volts. Do you believe that? So it actually works. It's almost 100 years old. That is incredible. I am just happy as a clam. I guess I'll shut it down here. The tuning dial shaft is broken, and I have an idea how to fix that. And I'll need to get down to my lathe in the barn, and since the weather's kind of cold now, that's going to be a drag. So I don't know when I'm going to get to that. But now that the radio works, I can go in and put these capacitors in more securely secured. And wow, that is so cool. You never know. I think I said earlier in Old Majestic I worked on, the IF transformers were just completely smoked. So anyway, let me make it a little safer with the soldering, and we'll be back. Okay, I decided to take advantage of the balmy 45-degree weather outside, as I knew I'd have to go down in the barn to do some lathe work to work on this tuning dial. So there's a 1/4-inch shaft that goes into here, knob being on the front, and then on the back side there's a 1/4 inch bushing, and then in here there's about an 1/8 inch shaft. Now the problem is let me put it to you this way. The original piece looks something like this. It's a 1/4 inch shaft with a grooved out spot where it's 1/8 of an inch and then 1/4 inch on either side. But getting it in here without completely disassembling the tuning dial, that's not going to work. And it's interesting. So you can see in there the 1/8 inch shaft turns this part. And I kind of wondered how it keeps from slipping, but there's actually inside here, there's a spring and there must be a cam up here. And there's always downward tension on this thing. So you all the way up and then see it. Oh, it's kind of hard to see it. Anyway, there's spring tension downward this way on the shaft. So on the back side here, there was the broken off piece, and you can see where the 1/8 inch shaft was. And that was incidentally seized in there, and I actually soaked it for a while with the trusty liquid wrench to get it out. And I was getting ready to use a cigarette lighter to heat it up to pop it out, but it actually did come out without too much of a fight. So anyway, with this, I made it like this. 2 pieces. Got your 1/4 inch shaft, your 1/8 inch shaft, and then a sleeve with 2 teeny tiny set screws. So we can put this thing together without completely disassembling this thing. So on Amazon they had this neat little kit with these tiny set screws, and they are metric 2mm. So I have some pictures here of the lathe work. I didn't film it because it was so damn cold. I didn't want to mess around with setting things up, so I just snapped a few pics. And what I did was, so I don't really have the tooling to make something like this. I just plunged into it, turned it down, kept turning it down, and that's what we got. And that's the sleeve piece, just drilling a hole in with a 1/8 inch bit. So it was fun. The lathe I have is a big 16-inch South Bend, and it's very old, lots of slop. It's amazing. I got this thing, I mean, it's within 1/1000th. It's nice and tight. So I just need to get it in there, and I got to put pressure on that to get it in and tighten these set screws. And and I did on the eBay, I did happen to find the exact tuning knob we need for that. So that's kind of cool. So I guess I'll put this thing together. I guess I'll try doing it on camera. I don't know how well it's going to work, but we'll see. So, oh, it may not be as bad as I thought. Ooh, tight, tight, tight. Yeah, see? Oh. It does slip a little bit. Oh, if I put the sleeve on the other side, let's see. That puts a little more downward tension on it. There we go. Huh. I thought there was going to be a tighter fit on here. I have to see if there's maybe some grease or something on there because it does slip a little bit. So let me investigate that and we'll be back. Okay, I figured it out. It had to be squeezed together so the shoulders of each side of that 1/8 inch shaft was gaining friction on here. So the shoulder, you can see the wear marks on there. There you go. You can see the shoulder bites in a little bit, and then the spring pressure on the top part, and then the shoulder on the other side. So it goes now without slipping. So all right, and then our that's our knob. So now at least we can tune it. So I'll finish up soldering the components in, and we'll be back. Okay, we got our tuning dial put back on, and it works good. I lubricated the ball bearings and the tuning cap, and I also took a Q-tip and cleaned the friction point where that brass rod we made comes into contact, and I also took a little piece of sandpaper and just scuffed that a little bit. And we got good consistent movement on our tuning with no slippage, so hopefully that'll be good. I don't know, the greatest design in the world, but anyway, so the next step, we're going to investigate the two potentiometers in here. So the first one we're going to look at is the tone control. This one here. So we're going to open it up and see what's going on inside these really old variable resistive potentiometers. I think have a paper element in there, and I got a feeling that probably if that's in bad shape, then we're just going to have to put a different pot in, but maybe we'll get lucky, I don't know. So we'll drill out the rivets and open it up, and all right, let me finish drilling that off camera. Be right back. Alright, sorry about that. The drill was kind of wandering around on our little rivets there, so this is the innards, and this is our paper element. It doesn't look too terribly bad. It's kind of interesting. So there's this ball on here that rotates, and it puts pressure on this flexible piece of metal, and it makes contact along our element. So sometimes you can clean the back side of here where it makes contact, and restores the function of our resistor. So let me get some cleaning stuff, and I'll be right back. Alright, I got this metal contact pried up, and you can see there's a piece of dirt, or there's something on there that is likely making our potentiometer not work. So I've had luck with cleaning that off, and I was able to take an ohmmeter and go across here and measured 1.3 meg. It's probably a 1 meg-ish pot. So we'll take a cleaner here and clean the underside. We'll be right back. Alright, this is kind of difficult to show, but there's that material on the paper element just from aging, I guess, lifts off there and sticks to that metal contactor. So I just use those little brushes without any fluid on it or anything. We don't want to deteriorate the element anymore, and just kind of brush that off there, and we'll see if it works. Alright, I got it put back together, and we're going to have to replace it. It works a lot better than it did, but it's just that resistive element in there. Like I said, it's like thick paper with lead pencil graphite on it. Well, it's not lead pencil, but pencils are graphite. But anyway, so I'll just show you the before it just was like 3.5 megs, and see, it just bounces around. It's just no bueno. But maybe the one good thing you can get from this is I got this metric teeny tiny stainless steel screw kit that you can use to replace these rivets, and then you can take stuff apart and whatnot. So that's kind of handy to have. These are 3 32nd rivets, and these 2.5 millimeter cap screws work real nice to put it back together. So, but it's a shame. I didn't think we were going to be able to salvage it, but it was worth the old college try.
Well, I'm going to give it the old college try.
Are you going to go to class?
No.
So, the one thing at this pot I'm not so much care about, but this one that has the on-off switch, it has this nice, let's see if I can get, I don't know, like a you'd have to be old enough to remember how old TVs and old stuff turned on. It's just this nice springy power switch. But, you know, there's not a whole lot you can do about it. So we'll replace this pot. Like I said, I measured it. It was about 1.3 meg, and it's probably aged. It was probably a 1 meg. And I think this one, I don't remember what it is. I'll have to measure that one. So let me dig through my pot stash. Pot stash.
Ditchweed. Boo. The old Alibaba. Magic Dragon, Bumbleachi, Yellow Submarine, Black Bart, Dr. Giggles, Kentucky Blue. You know what I'm talking about. I'm talking about railroad weed. That's right. The devil's parsley, skunk, splim, splam, mooster, side salad.
And I'll be back. Okay, I found for our tone control pot, I found a nice 1 meg. Brand new, that will work. And for our volume control, this one measured 250K. That one Warwick Schematic had the volume pot at 100K. This one's a 500K. We'll put this in and see if it works. And just, we can cut that knurled end off. And that should work. So I'll get all this put in here and see what we got. Alrighty. Got this thing back together. I had to change the pot that I originally selected. It actually was a bad pot. So, oh, and I did put a new power cord in it. And I got to tell you, this thing is an unbelievable performer. I'd say it's the best performing radio I got. It's so sensitive. When I was playing with it earlier, when I turned my computer on, now it's getting some static on the lower end. But gets 670 the score. I believe WGN, WBBM, WLS. Don't know what that is. Don't know what that is. Gets my local station real good. The tone control works. We use a 1 meg pot. I think there's another station up here. Yeah. So I got to tell you, I'm just surprised that a radio that's almost 100 years old performs that good. So, being that it's working so well, I'm not going to mess with the alignment. I don't know, these old IF transformers, I don't know if those slugs might be stuck, possibility of breaking something. The fact that it's working so good, I'm just not going to mess with it. So, the only thing left is the cabinet, and that's in pretty sad shape. I'm gonna have to get a little more experience working with wood restoration before I mess with that. So I think that pretty much wraps it up for this. I don't think I'm forgetting anything. So we'll be back. We'll have some final thoughts. Okay. So usually this part of the video I show the radio back in the cabinet, but I still have work to do on that, and need to cut the shaft off that. I might replace that pot with one with a shorter stem on it, because I might need one with a longer stem in the future. I found a lot of audio pots on the flea base, so maybe I can find one shorter, but anyway. So really the first thing we did with this, I had to figure out what it was. I thought it was a Detrola, and I didn't. And now I believe it is. So then we painstakingly made a schematic, which helped out a lot. And incidentally, that resistor that was burned was the plate resistor for the 55 tube. So I don't know if why exactly that failed, but it did. So then we made a tuning shaft for it, and that worked out nicely, so we can tune it. And then we replaced the volume and the tone pot. And for the tone pot, we used a 1 meg, and the volume pot, 300K. You could probably use 100K up to probably a 1 meg would work just fine. So that went well, and it turned out we didn't need to align it, which was good. It's very, very, very sensitive. It brings in stations I don't think any of my other radios can bring in. So that's a good thing. I really like this radio, and hopefully I can get that cabinet looking good and make this a presentable radio. But this was a very fun restoration. I'm glad it wasn't a dud. It would be just a doorstop junk. So hopefully in a future video we'll do that cabinet restoration. But otherwise, it was a great video, a lot of fun. Hope you enjoyed it, maybe learned something. And thanks for watching.